Somewhere in West Antarctica right now, a piece of ice, roughly the size of Florida, is quietly cracking apart, and the scientists watching it happen are checking on it every single day. Not every week, every day. That's how fast this is moving. This is Thwaites Glacier, better known by the name that sounds like something out of a disaster movie, the Doomsday Glacier. And in 2026, researchers say it's about to lose the last thing that's been holding it back. Let's start with why this one glacier, out of the thousands of glaciers on Earth, gets its own ominous nickname. Thwaites sits along the coast of West Antarctica, and it is enormous, stretching across an area comparable in size to the state of Florida, over 2 kilometers thick in places. On its own, the ice sitting on land at Thwaites holds enough water to raise global sea levels by roughly 65 centimeters, a little over 2 feet. If it all melted and flowed into the ocean, that number alone should get your attention. But it's not actually the scariest part of this story. Thwaites doesn't sit alone. It acts like a cork in a bottle for a much larger, much more dangerous mass of ice behind it, the West Antarctic Ice Sheet. That ice sheet contains enough frozen water to raise global sea levels by an estimated 3.3 meters, close to 11 feet, if it were ever fully destabilized. Thwaites isn't the whole threat. Thwaites is the plug, and right now, that plug is failing. Here's how a glacier like this actually holds itself together, because it's not just one giant solid block sitting still. At the front of Thwaites, where the glacier meets the ocean, there's a floating extension of ice called an ice shelf. Think of it as a natural brace, jammed up against the seafloor and the coastline, physically pushing back against the glacier and slowing down how fast it can slide into the ocean. As long as that ice shelf stays intact, it acts like a doorstop, holding the whole system in place. Scientists have spent years watching that specific piece of ice, the eastern ice shelf of Thwaites, because it's the last significant brace still holding on. In early 2026, researchers published findings showing that this eastern ice shelf has been fracturing in 2 distinct phases over the past 2 decades, with cracks spreading through its structure in a pattern researchers compared to a windshield slowly shattering under repeated stress. And by mid-2026, scientists from the International Thwaites Glacier Collaboration, a joint research effort between the United States and the United Kingdom that has been studying this glacier since 2018, issued something more specific and more urgent. They believe this remaining ice shelf could begin breaking apart within the year, not within a decade, within the year. One of the lead researchers, a marine geophysicist with the British Antarctic Survey, described the last section of the shelf as poised to disintegrate, and saying scientists don't yet know exactly how the breakup will unfold, only that it's coming. Now, it's important to be precise about what this actually means, because headlines love to skip the nuance. The ice shelf breaking apart does not mean the entire glacier collapses overnight, and it doesn't mean sea levels suddenly jump by 2 feet next year. The ice shelf is already floating on the ocean, so its breakup doesn't directly add much new water to the sea on its own. The same way ice cubes melting in a already full glass don't overflow it. What it does mean is that the glacier loses its main structural brace, the thing that's been slowing its slide toward the ocean. Once that brace is gone, the land-based ice behind it, the ice that actually would raise sea levels when it melts, can start moving and thinning faster, with essentially nothing left to hold it in check. And the data on how fast that's already happening is genuinely alarming. A 2026 modeling study found that Thwaites has been losing ice more than 5 times faster than it was in the 1990s. Researchers project that by the 2060s, the glacier could be shedding somewhere between 180 and 200 billion tons of ice every single year. To put that in perspective, that's roughly the mass equivalent of filling a very large city's worth of water every year indefinitely, and accelerating. Thwaites already contributes around 4% of all global sea level rise on its own, from a single glacier in a single region of a single continent. So, why is this happening now specifically? Part of the answer lies not on the surface of Antarctica, but deep in the ocean surrounding it. A study published in 2026 examining the Southern Ocean found evidence of what researchers are calling a destratification event, essentially a breakdown in the layered structure of ocean water around Antarctica that used to keep warmer water trapped safely below the surface. That trapped heat is now rising upward, where it can reach and melt sea ice and glacial ice shelves from underneath, in ways that are harder to see from satellite images and harder to predict with older climate models. This is part of why researchers keep noting that Thwaites is deteriorating faster than earlier models predicted. The ocean itself is behaving in ways that weren't fully accounted for. Let's talk honestly about the timeline, because this is where responsible reporting on this topic actually matters. The International Thwaites Glacier Collaboration has been clear that a complete catastrophic collapse of the glacier within the next few decades is considered unlikely. This isn't a Hollywood scenario where the whole thing crumbles into the sea next Tuesday. What researchers are confident about is that the retreat is going to continue, and it's going to accelerate. Ice sheets, once they start losing structural support and start retreating past certain critical points, tend to keep going because the physics driving the retreat, warmer ocean water reaching further under the ice, deeper channels opening up beneath the glacier, more surface area exposed to melting, tend to reinforce themselves rather than self-correct. Scientists describe this as a tipping point, a threshold where, once crossed, the system continues changing on its own momentum, even if the original trigger doesn't get any worse. And that's really the core of why this glacier earned its nickname, and why it matters far beyond Antarctica. This isn't primarily a story about ice, it's a story about coastlines. Global sea levels have already risen more than 22 centimeters since 1900, and the rate of that rise has been accelerating from roughly 1.5 centimeters per decade across most of the 20th century to nearly 4 centimeters per decade in the years since 1993. Every centimeter matters enormously once you're talking about coastal cities, because sea level rise doesn't just mean water creeping slowly up a beach. It means storm surges that used to stop short of flooding a neighborhood now reach further inland. It means king tides that used to be a minor inconvenience start regularly flooding streets and basements. It means the difference between a hurricane's storm surge causing manageable damage versus catastrophic damage in cities that are home to hundreds of millions of people worldwide, from Miami to Jakarta to Bangladesh's low-lying coastal regions. Here's the part of this story that's genuinely difficult to sit with. Even if global emissions drop dramatically starting today, ice sheets don't respond instantly. They have enormous thermal inertia, meaning the warming and destabilization already set in motion over the past several decades will likely continue playing out for centuries, regardless of what happens with climate policy going forward. Scientists have a phrase for this: tipping points crossed, now commit the planet to consequences that unfold over timescales far longer than any of our lifetimes, sometimes described as ice sheets having long memories. That's not meant to be fatalistic. It's meant to be honest about the scale of the systems we're talking about. Decisions made about emissions this decade won't just affect this decade. They'll shape coastlines for centuries. So where does this leave us? Right now, in 2026, scientists studying Thwaites are watching the eastern ice shelf closely, some of them checking satellite and field data daily, because the timeline for its breakup has compressed from something that seemed distant to something that could happen within the year. That breakup itself won't flood the world tomorrow, but it removes one of the last natural breaks on a glacier that, alongside the ice sheet behind it, holds enough frozen water to reshape coastlines across the entire planet. Not hypothetically, not in some distant science fiction future, but as a physical process that is already measurably underway, accelerating faster than the models built just a decade ago predicted it would. The Doomsday Glacier isn't a metaphor. It's a specific, enormous, closely monitored piece of ice at the edge of a frozen continent most of us will never see. And what happens to it over the coming decades will very literally help determine where the shoreline sits in the cities where billions of people live, work, and raise families. Scientists aren't panicking. They're doing something more useful: watching closely, publishing what they find, and being honest that the ground, or in this case the ice, really is shifting under our feet. What do you think needs to happen next? Let me know in the comments. Until then, keep watching the ice.